Greetings! Generic high school physics student here, presenting to you my final project about the underwater physics of the hit indie game Subnautica. Developed by Unknown Worlds Entertainment and released in 2018, Subnautica is an open-world survival game about enduring the harshities of an underwater alien world, and escaping to your long-awaited freedom of going into debt with your sci-fi corporate overlords.
Welcome home to Alterra. Permission to land will be granted once you have settled your outstanding balance of 1 trillion credits.
The world we're stranded upon has the memorable name of Planet 4546b, but I'm just going to call the game world Subnautica. There are countless organisms, natural phenomena, and artificial constructs that are in motion at any given time in these waters, and we're going to meticulously and mathematically calculate one so that I hopefully don't fail this project. There are some hurdles we have to jump before we can start measuring anything though. Firstly, this is a video game and not real life. Certain things were not programmed or designed to 100% reflect how they should function within the real world. Along with that, some values aren't clearly defined or capable of being measured properly. I will attempt to estimate as much as I can with the information that the game provides, but if I am unable, I will use real-world approximations to try and calculate things properly.
The sea moth is a fast, safe mode of transport, but remember that swimming is good for your glutes and endorphin levels.
This is the Sea Moth, your one-person submersible that would carry you around Subnautica, and act as a shield from the massive fish that may try to eat you. Fun fact, it is actually described to be capable of operating in space as well. The Sea Moth has a top speed of 13 meters per second, and an acceleration of 5 meters per second squared. The time it takes to reach its maximum speed can be calculated by using the equation time equals velocity divided by acceleration. So, 13 meters per second divided by 5 meters per second squared is equal to 2.6 seconds. However, these values are in space, where there is no drag applied. So how can we find its speed underwater? Well, by using this handy dev info panel, we can find out that its top speed underwater is 11.25 meters per second, meaning drag reduces its velocity by 1.75 meters per second. However, it doesn't inform us of its rate of acceleration underwater, or the drag force applied to the sea moth as it moves. To find this out, we will be utilizing a three-step equation process. First, an equation to find the force acting upon the sea moth. Next, an equation to calculate and factor in drag applied by the water. Last, an equation to calculate the net force. But in order to do this, we need to find out the necessary variables for each equation. To calculate the force applied by the sea moth underwater, we will use the equation force equals mass times acceleration. But we need the following variables: the acceleration of the sea moth and the mass of the sea moth. To figure out the acceleration of the sea moth, I will use the dev info panel. I can figure out two pieces of information: the time passed and the time it takes to reach its top speed. I can precisely measure the acceleration time to its max speed by subtracting this large number from this large number to get 5.8 seconds. I can then calculate acceleration using the formula acceleration equals velocity divided by time. And then upon plugging these values into the equation, I get 11.25 meters per second divided by 5.8 seconds equaling 1.94 meters per second squared. Calculating the mass of the sea moth is a bit more difficult. The mass of the sea moth, unfortunately, is unable to be accurately determined. Unknown Worlds Entertainment doesn't provide any way to research or calculate the mass or weights of the physical objects within Subnautica. So to calculate, we will need to use a rough approximation of weight using a real-world reference. The sea moth has been noted to be seemingly inspired by the real-world Sea Explorer 3 by the private submersible company U-Boat Works. But interestingly, after the game's release, U-Boat Works released a new submersible model dubbed Nemo, which I don't think it is out of the question to say was inspired by the sea moth. The Nemo submarine's weight is 2,500 kilograms, but has greater dimensions than the Seamoth. So to get the best approximation, we will subtract the volume of the Seamoth from the volume of the Nemo by finding Nemo's density, then multiplying that value by the Seamoth's dimensions to get its approximate weight. We will be using two equations here. Density equals mass divided by volume, and weight equals density times volume. To get the density of Nemo, we will divide 2,500 kilograms by 10 meters, equaling 250 kilograms per meters cubed. To get the weight of the Seamoth, we will multiply 250 kilograms per meters cubed by 4.50 meters cubed, equaling 1,125 kilograms. Now, inserting everything back into our original equation, we get 1,125 kilograms multiplied by 1.94 meters per second squared, equaling 2,183 newtons of force. To calculate the drag force applied by the water onto the Seamoth, we will use the equation force of drag equals 1/4 of the density of the ocean times the area from the front multiplied by velocity squared. But we need the following variables: the density of 4546b's water, the width of the Seamoth, and velocity. In order to figure out the density of Subnautica's water, I'm just going to equate it to the density of water on Earth. Generally, water is the same composition of 2 hydrogen and 1 oxygen atoms, no matter where you go in the universe. Factors such as purity can alter density, but we will assume that water here is the same as the water on Earth, given that this is a habitable planet with life. The width and velocity of the Seamoth we already know. It's 1.5 meters and 11.25 meters per second respectively. When inserted into the equation, we get 1/4 times 1,030 kilograms per liter times 1.5 meters times 11.25 meters per second squared, which is equal to 488 newtons. Now to finally calculate the net force of the Seamoth as it moves through the waters of Subnautica, we simply insert both of our previous composite force values into the equation for net force, that equation being Fnet equals force minus force of drag. So, inserting our values, we get 2,183 newtons minus 488 newtons, which is equal to 1,695 newtons of force. I'm just about to cross the 8-minute mark, so I'll have to wrap it up here. I wanted to talk about some other things, like the possible difference in gravity between Earth and Subnautica, and the buoyant force of these little critters called floaters. But I suppose I've already yapped enough as it is. Thank you all for watching my presentation, and I bid you a pleasant day.